Hello guys, we're going to have a look at sketching linear graphs in this session. Now this is an area of tremendous confusion for a lot of students in years 9 and 10, and for some reason it seems to come clear after that. I think it's something to do with the level of abstraction and the time when your brain is ready for the level of abstraction in this kind of thing. So I hope I can make it easier for you in this session. So let's ask the question, what is a linear graph? Well, it's a straight line graph. That's the answer to that one. It's very simple, isn't it? Now, we have this is the form of the equation which forms a linear graph. Y equals m times x plus c, where x is known as the independent variable, or the value that you can choose, any old value that you choose, and then we can change its value, choose its value, change its value, plug it into the rule here to get y, okay, to get y. Now, y is the dependent variable because it depends on the value of x which we choose, okay, according to the rule. That's how we define an independent variable and a dependent variable which depends on the independent one. This m little beastie here is the gradient or steepness of the graph. Just think of the steepness of the hill if the graph was a hill. Okay, and c, the term c, is what's known as the y-intercept. This means the y value where the graph crosses the y-axis. Now this will all become clear as we go through this stuff, but that basically is the form of a linear equation which can be turned into a linear graph. Okay, now gradients can be positive, which means that they go uphill as you move from left to right across the page in the same way that you would read a book. Okay, they go up. Okay, now they go up, and the last letter of up, guys, is P for positive. Well, how do you like that? Or they can be negative, which means that they go down, right? They're going down, 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 down. Okay, and the last letter of down is N for negative. Okay, now mathematically the gradient is defined as the rise over the run. Now the rise is the amount of vertical change, and the run is the amount of horizontal change which occurs over any chosen section of the graph. Alright, that's pretty cool. Now we can represent x values on a horizontal number line. Okay, and we represent y values on a vertical number line. Okay, now the number line crosses, or the two number lines cross, where x and y both equal naught, and then we have this beast called a Cartesian plane. Cartesian meaning kind of like a map. That's really the name that we get for maps and map making. That's what it looks like. Okay, we've got a horizontal number line here for the x, and we've got a vertical number line there for the y, and they both meet where x and y are both 0. These are the number lines we use to draw linear graphs. Okay, we draw the rule connecting x and y as a straight line. For a linear graph, it'll be a straight line like that. Okay, and we look up values of x and y connected by the rule using this line. It's that cool. Okay, nothing mysterious about it, but you'll need to practice to get used to it, guys. So, what is a linear graph continued? The method of finding y for a chosen value of x according to the rule, using the line on the graph, which is what we do to find a chosen value of y, or a value of y for a chosen value of x, or vice versa for that matter. It's similar to using a street directory. So for example, you would track up and down from an x value until you reach the line, up or down I mean, from an x value till you reach the line, and then you would track right or left as appropriate from the point on the graph that you have just found, intersected with, by going up and down from your x value, from the line left or right to the corresponding y value on the y-axis which belongs to your chosen x value. These points that are on the graph which connect an x value with its corresponding y value according to the rule are referred together as a coordinate pair. X, comma, y. The value of x, then a comma, then the value of y, and then put inside brackets. Okay, now please note that the x goes before the y, just the same as they do in the alphabet, guys. Now, having done all that and got all that preamble under our belts, we can look at plotting a linear graph, and then after that we are going to sketch some linear graphs. Alright? Here comes the plotting. So we have to plot a linear graph defined by the rule y equals 2x minus 5 for the x values minus 3, minus 2, minus 1, 0, 1, 2, 3. Well, I think this will be fun. Here's a table. Now I'm going to put my x values in. There they are, minus 3, minus 2, minus 1, 0, 1, 2, 3. Now, what we do now is we work up. We work up to the rule. So we have to basically take an x value, multiply it by 2, and then subtract 5 to get y. So let's first of all multiply those x values by 2 and fill in that second row. So 2 times minus 3 would be minus 6, then minus 4, then minus 2, then 0, because 2 times 0 is still 0, then we would get 2, 4, 6, yes? Now let's take 5 off, right? We're going to do 2x minus 5 now, which, guys, is our bonanza. It's our y value. So, righto, now you tell me, what is minus 6 minus 5? Do you remember? Do you remember how to do that? Well, it's minus 11. Did you get that? I hope you didn't get minus 1 or something like that. Remember, the 6s and the 5s, the 6 and the 5 are both on the negative team, right? So that you've got 11 men on the negative team, if you like, or 11 ladies on the negative team. That makes them 11 of them. Yes, that's how you do that. Righto, the next one is minus 9, then we've got minus 7, and then we're going to get minus 5. Now, what's the next one? Yes, minus 3, and then we've got minus 1, and then we've got plus 1. Now that, guys, is our line. That third row is our y values row, which corresponds to these chosen values of x. So x was the independent variable. We just chose the values from minus 3 up to plus 3 inclusive, and we used the rule to work out what y must be, because it depends on the values of x that we chose, right? Over the screen we go. Now, we're going to plot these in the way that I described earlier, using a kind of a street directory approach. So the first one, there's some, I need a scale first. And if now look, see, you choose x is minus 3, you go vertically, right, like you would for a street directory, away, vertically out and away from the x-axis, right? Then you've got to choose the point, that's the corresponding point for x is minus 3 as y is minus 11. So you do the same thing for the minus 11 in the direction from minus 11, which is going to intersect with the point that you've already drawn from the x is minus 3 spot, right? You get really good at this after a while, so that is our first point. Okay, now we've got to go for x is minus 2 and y is minus 9. Okay, there it is, and there's our second point. Now we're going to go from x is minus 1 and y is going to be minus 7. There it is, and there's our point. You see, look. We're going to get a beautiful straight line out of this. Isn't this exciting? Well, I think it is anyway. When x is 0, y is minus 5, so I've just put that point in there, right? It's right on the y-axis, that one. Now, when x is 1, we've got y is minus 3. There's the point. Great. Now, what about x is 2? Yeah, y is minus 1 there. Very good. And then when x is 3, y was plus 1. So that's going to be on the other side of the x-axis, just to mix it up a bit and make it even more exciting. There's our point. Now, guys, look at that. I never saw a more beautiful straight line in the making in my life. And we are going to join them up. Here we go. Ooh, there it is. There's our beautiful straight line, and that is, now we've got to label it, that is y is minus 2x, oh no, it's not minus, it's plus 2x minus 5. That's how you do it. That's how you plot a graph, right? Now we're going to do sketching a linear graph, basically, which means we're only going to use 2 points, because you need 2 points to sketch a line, to fix what a line is going to look like. So this is really the shortcut approach, sketching a linear graph from its rule. These ones here I'm referring to are for graphs which slope from left to right. Right at the end of this presentation I'm going to do a couple of weirdo ones, which are either horizontal or vertical. So all of the following, until I get to that point, is going to be for graphs which slope up or down from left to right. Okay? Now, there are 2 different techniques that we can use to do this. 2 different separate techniques, and we're going to cover both of those now in the following screens. The first one is called the x and y intercept method, and the second one is called the gradient and y intercept method. Alright? Yes, now let's do the first one. Here's the x and y intercept method. There's a question for us. We have to sketch those graphs, which means, remember, we only need 2 points to do that. So we're going to find 2 points. And the points we are going to find, guys, are the x and the y-intercept points. Now, let's just go through this. I've sort of jumped the gun a bit. This method is used when the graph does not pass through the origin, which is x is 0 and y is 0, right? That's where the axes cross, okay? And when the rule is not written in the form this. Well, usually when it's not in the form. You can do it when it's written in the form this, but you know, when it's written in this form, it's more convenient to do it another way. Okay? So let's just continue. We need only 2 points to draw a straight line. In this technique, they are the x and the y intercepts, as I was saying before. Now, this is what you need to know. The x-intercept occurs when y equals 0, and the y-intercept occurs where x equals 0. Now, the x-intercept is where the graph crosses or cuts through the x-axis, and the y-intercept is where the graph crosses or cuts through the y-axis. All right? Here is an example for you. Here is an example for you. This one here, I've found a y-intercept of plus 6, and I've found an x-intercept of plus 3. Now, there's a graph. Now, you see how I only need 2 points to do it? That's why this is a sketch graph, okay? Now, I want to illustrate the point that at the y-intercept, which is where y equals 6, right? If you draw a vertical line from that point, you will hit the x-axis at 0. So in other words, when you have the y-intercept, whatever point, whatever value the y-intercept is, always dropping vertically along the y-axis from that point, you will hit 0x. That's why the value of x at the y-intercept is 0. Correspondingly, with an x-intercept of 3, if you draw a horizontal line from there to the y-axis, you'll get y equals 0. You see, y is 0 at this point, y is positive up there, y is negative down there. But at this exact point, y is negative. Alright? That's what I mean by saying that the x-intercept occurs where y is 0 and the y-intercept occurs where x is 0. Alright, I'll stop rabbiting on. Now, number A, let's do this now. We're going to do the intercept method. So we've got 2x plus y equals 6. The x-intercept occurs where y is 0. So we substitute y is 0 into that equation, right? Into this equation here, right? We make y 0. What do we get? 2x plus 0 equals 6, and therefore 2x equals 6, and therefore x equals 3. So that is our x-intercept. Ha ha! Which means we've got that's the x-intercept. So the y-intercept occurs when x equals 0, and therefore we substitute x is 0 into the equation, and therefore we get y equals 6. So that must be the y-intercept, and therefore this gives us the 2 intercepts. Okay, now putting them as coordinates, x comma y, the x occurs where y is 0, so it's 3 comma 0 for the x-intercept, and 0, 6 for the y-intercept. That's where x is 0, y is 6 for the, and basically it's this graph over here. I worked it out in advance and just used this example, which is actually the solution to this question. Yes, 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 I know. So I'm trying to be clever. Don't worry, I'll make a mistake sooner or later and I'll come down off my pedestal. So yes, that's the graph of 2x plus y equals 6. Good show. Now we'll do the second one. Now B for you and me. Y is minus 3x minus 12, and the x-intercept occurs at y equals 0. Same technique, guys, same technique. Substitute y as 0 into that, we get that. Now we've got to solve that for x, right? There's a little bit of algebra, but we're not afraid of algebra, are we? We can do it. So solving for x, we're going to get this. We add 12 to both sides, and we get that little equation. Cleaning up, we'll get, and I've just swapped sides just to make it a bit easier with the x's on the left. So I've got minus 3x plus nothing from they obliterated each other equals plus 12. That plus 12 there, I've put him over that side. Dividing both sides by minus 3 to get x, we just get x is minus 4, because that's a plus 12 and I'm dividing by minus 3. If the signs are different, the answer is minus. Alright, so therefore that's my x-intercept, minus 4, and 0 is the y, of course, right? Now let's do the y-intercept now. That means x is 0, so we're plugging that in as 0, minus 3 times 0, minus 12, which is easy. That just gets us minus 12. So therefore our y-intercept would be x is 0, y is minus 12. Now, guys, we're ready to sketch away. There's a nice little graph all set up for you with scales and everything. Now let's put our intercepts on. There's the x-intercept, right, minus 4, x, y is 0. Here's our y-intercept, x is 0 and y is minus 12. Now all we've got to do is 2 points make a line, guys, if it's a straight line, and we just join them up. Beautiful job. Alright? Do you see how easy it is? That's the intercept method. That's the intercept method, guys. X and y intercept method. Yes, there's the equation. We've got to do that. Now, here's the gradient intercept method, which is a little bit annoying, actually, but we have to do it. So, what am I saying here? This method is used if the equation is in this form. Y equals mx plus c, where m represents the gradient and c represents the y-intercept. And I went through all that on the first screen, didn't I? Now, this is the steps we've got to do. We've got to basically plot a point at the y-intercept. That's the first thing. That'll be on the y-axis, right, where x is 0. We start with that point. Now, step 2, we write the gradient in the form m equals rise over run. Now, that's very important because that tells us how much run we get for how much rise. So, and I'll show you how to do this in a moment. But then we start from that y-intercept point, which we talk about in step 1, and we move the number of units suggested by the we move the number of units for the run, and then we move the number of corresponding units for the rise. That's what that's trying to say, okay? Then, oh well, I've said it differently. 3 and 4, steps 3 and 4, I do it differently. I do the run first, and then I do the rise. They're doing the rise and then the run. Doesn't really matter, but I like doing the run first. Step number 5, and then we just rule a straight line through these 2 points. Now, I know that all sounds like gobbledygook. I will show you, don't you worry. This is one. Well, plot the graph of y equals 2/5 of x minus 3. Alright, that's okay, guys. Now, let's just analyse what we've got here. Y equals 2/5. That's 2 over 5 of x, where this term here is the gradient term, this term here is the y-intercept. So the y-intercept, guys, is minus 3, but I think I've written all that out. Yeah, mx plus c. M is 2 over 5 to keep us alive. Now, that bit's the rise, that bit's the run. Okay, the rise goes up, the run goes across. Okay, so that's our recipe for success in terms of that m term. Alright? And the c is minus 3, that's the y-intercept. Now, come on, we're going to do it. We're going to start with the y-intercept. We're going to put a point there. We start at the point where the y-intercept is occurring, which is minus 3, as you can see here. Now, you watch this. This is really cool. We're going to go to the right, left to right by 5 units for the run, and then we're going to stop there and we're going to track up another 2 units for the rise, and that'll give us our additional point where we stop. Okay, watch this. Right, there we go. We went 5 units to the right. Now we're going to do 2 units up. That gives us that. Now, so therefore, this point here must be another point on the graph because we've done a run of 5 and we've done a rise of 2. That must get us another point on the graph, okay? Because the graph obeys that rule. There it is, there's our point. So that point there is now, if you've got to work this out, okay, we started off at 0 and minus 3, so we went along by 5, so that gets us 5 for the x. We went up by 2, so this point here gets us minus 1, which is 2 more on a number line, if you like, than minus 3. And we just draw a line through those 2 points, because remember, you only need 2 points to do a straight line. Mighty fine. My goodness, we're cooking along here. Now we're going to do sketching graphs of the form y equals mx. Now these are peculiar little beasties because they don't have a c. Y equals mx plus c. You see there, y equals mx instead of y equals mx plus c. So c must be 0. Yes, it must be 0. This means there's no y-intercept. Yes, I know it's sad, but we have to adjust to some facts in life, and that's one of them. So this is, it passes through the origin. That's the origin. See, x is 0 and y is 0. That's where the axes cross, right? That's why it's got no y-intercept, right? It's right on the bullseye, on the origin. Okay? So, since we need 2 points to sketch a straight line, and we already have the origin, and we can't use any of the intercepts because there ain't no intercepts, guys. So what we do is we make up another point. We need one more point. So we do this by choosing any convenient value of x, all right? Any convenient value of x. So, and we find the corresponding value of y from the rule. And then we use this as our second point, and then we just join those 2 points up and Bob's your uncle. So then we can sketch the graph using the origin and the second point. E.g., if that was all unclear, come on, I'll show you. Y equals 3x. We can see that y equals 3x plus nothing. There's no c term, so this is one of those strange beasties that goes right through the origin, guys. Yes? So there's no y-intercept and the graph passes through the origin. X is 0 and y is 0. So we've got to choose another value of x to use the rule to find the corresponding value of y. Okay? Y to find y. So if x was 3, I've just picked 3 at random, guys, no particular reason. It was a little bit distant from when x is 0, just to get me a little bit of space on the graph so I can sort of more accurately sketch the line. That's the only reason I chose 3. So if we chose 3, therefore y would be 3 times x, which is 3 times 3. That's the rule, 3 times x. 3 times 3 is 9, so y would be 9 when x is 3. So there's our point. There's our second point. And we chose it and basically came up with it ourselves because we just chose a random value of x which was convenient for us. Now we're going to sketch a line joining the origin, because this graph goes through the origin, and our point that we just got there. Yes, watch this. Okay, there's the origin point, and doing our street directory approach, there's 3 and x is 3, y is 9. There's the second point. Put a line through them, guys, and Bob's your uncle. There it is, and label the graph, and we are done. We are done, and we had fun. Now, these are the weirdo ones I spoke to at the beginning of the video. These are the ones that don't slope upwards or downwards as you move from right to left. They're a bit peculiar. So it is possible to have an equation for a straight line that contains only an x term or only a y term. Yes, yes, I know, truth is stranger than fiction, but that's the truth. These equations can be written in the form y equals c or x equals a. You see, look, this y equals c has no x term in it, and x equals a has no y term in it. Okay, and these are both constants. So y equals c would mean y is always c, always the same value, irrespective of what x is. And x equals a similarly means that basically no matter what value of y you choose, guys, x is always going to be a. So what that looks like is lines of the form y equals c, where y always has the same value, are flat, horizontal lines parallel to the x-axis. They have a gradient of 0 and a y-intercept of c. Okay? Because they don't go up or down, therefore the gradient is 0. There's no slope, no steepness. Now, lines of the form x equals a, these beasties, no matter what value of y you pick, x is always the same value. So they are vertical. They are vertical lines parallel to the y-axis, and they have an undefined gradient because rise over run, there's no run. So you actually, if you tried to do rise over run, you'd be having some rise dividing by no run or 0, and you can't divide by 0. That's why they say they're infinite or undefined. And yes, that's the deal. Righto now. So these lines are not sloping lines. They do not look like that or that. They do not have a slope, guys. They are either vertical, which is like that type, the x equals a type, or they're horizontal, such as the y equals a type. So, come on, we're going to do this and then we'll get out of here. Sketch graphs of the following linear equations. Y equals -3 and x equals 4. Alright, now I think you know what to do, guys. This is the first one. There's a graph. Now, come on, you think about it. Y is always -3. Now, you pick a point on the graph where you know y is -3. Well, this one here. Yes? But over here, when this value is here, y is still -3. This value of x here, y is still -3. This value of x here, y is -3. This value of x here, y is -3. This value of x here, y is -3. It doesn't depend on x. Y is always -3. Are you getting the deal? Larishy B, Jim. There's the graph, right? That's it. I know, it's weird, but that's it. Now, this is B now. X is always 4, irrespective of what y is doing. X doesn't care, it's always 4. It doesn't depend on y at all. So, come on, you show me a point where x is 4 on this graph. Well, here. Yes, but even for this value of y, x is still 4. Even for this value of y, x is still 4. For this value of y, x is still 4. And all these values down here of y, x is still 4. So, come on, what does it look like? Yes, there's my scale for the y, which I forgot to put on, sorry. There it is, guys. There it is. X equals 4. Okay? Yes, I know, it's fantastic, isn't it? So, look, I hope I've made this simple for you to understand, and if you don't get it straight away, just go back and have another look and pause the video and have a look what I'm doing. I'm sure you'll get it, okay? And this is a summary. This is a summary which I won't go through now. It takes too long, but I want you to pause the video and see whether all that stuff you see there makes sense to you. And if it does make sense, hey, more power to you. And if it doesn't make sense, please ask, okay? And you're a star and you'll go far, providing you practice, okay? And I'll see you in the next exciting video. Bye-bye.